we'll go for the problems. Can anybody read what is the problem given? The first problem. Yes. Hello.
Air stream at 30 degrees Celsius.
Huh?
Air stream at 30 degrees Celsius.
Air stream at 30 degrees centigrade. Huh? Air stream. Okay, I'll go with that. Air stream at 30 degrees centigrade is moving. That means it is blowing. It is blowing at 0.5 meter per second across a 10 watt electrical bulb. Oh, okay. See, that means till now, whatever you have covered, it is with respect to the plate. That is with respect to the plate. If the plate is kept, and if you already know how to solve, if the flow is Reynolds, if the flow is turbulent, if the flow is laminar, how to solve, you know all that. So all the type on the plates I covered. Now I'll go with spheres and cylinders, because here in the syllabus he has mentioned to solve the problem based on the plates. If the flow is taking place above the plates, how the effect will be, and based on the cylinder. If the flow is taking place over the cylinder, on either side, the flow air flow will take place, and heat transfer will take place from air to the body. How it will take place. And one more is sphere. If the air is blowing over the sphere, how to solve the problem? Procedure is same. Remember, whatever may be the shape, procedure to solve the problem is same. That is, first we'll find T film, then we'll find out the properties, then we'll go with the Reynolds number, then we'll go with, after Reynolds number, we'll go with Nusselt number, then equating that Nusselt number to find out the value of H, then substituting that H in the Q. We will get the value of Q. Procedure is same. But here, in the plate, based on whether we should find out first whether it is laminar or turbulent flow. There is different formula if it is laminar, there is different formula if it is turbulent. If the plate is having both laminar and turbulent region, then we have to find out Q for laminar, Q for turbulent, find out, add up those two, we'll get final Q. What is the total Q from the plate? But in this case, we will not get the laminar flow or turbulent region separately. We cannot define the laminar region, turbulent region separately. If the flow is taking place, either the flow may be laminar or the flow may be turbulent. That we are going to do in the problem. That means the length of the problem, if it is cylinder or a sphere, is lesser compared to the plate. Why? In the plate, if the flow is taking place, it may undergo for the laminar region, then it may also go under turbulent region. So we need to calculate Q here also, Q here also. There are some problems where completely it is a laminar flow, so we found out only Q. There are some regions where the turbulent is very small, laminar is very small, and the remaining is turbulent. There also you get 1 Q. In these two cases, of course, the problem length of the problem is less. But in some cases where the laminar flow is also considered and turbulent flow is also considered, then we are going to divide the problem into two parts. Here we'll find out Q, here also we'll find out Q. Then we'll add these two Q to find out the total Q. Correct? But in the sphere and the cylinder, that problem will not arise. So whatever the air it is flowing, initially we'll come to know based on the Reynolds number whether the flow is laminar or turbulent. That's all. Entire throughout the region it will be laminar, or throughout the region it will be turbulent only. So the length of the problem in cylinder and sphere is small, lesser compared to the plates. So now we completed all type of problems with respect to the plates. Not even even a single concept I have not left out. I covered all the topic in the horizontal plate. Next, we will go with this next concept, that is cylinders and spheres. So in this problem, what he has given, the air stream at 30 degrees centigrade. So T infinity is equal to 30 degrees centigrade is moving at a speed of, that is U infinity, 0.5 meters per second. The air is flowing at speed of 0.5 meter per second. Across what? Across a 100 watt bulb. That means there is a bulb. So this bulb, we are going to consider it as a sphere. That's all. There is this bulb, 100 watt bulb of diameter how much? So he is not given diameter. He is telling which bulb it is. Incandescent bulb. So incandescent bulb is, it is, somebody may ask, so why can't we take a tube light? Tube means fluorescent light, fluorescent tube. So he has given clearly that the given problem is based on incandescent bulb. That They'll consider the bulk as sphere. Okay. Now we'll take up as a sphere. And what is the T wall? Temperature of the sphere or temperature of the bulb? It is 130 degrees centigrade. If the bulb is approximated by a 60 diameter sphere, that is also given. Diameter is 60 into 10 to the power of minus 3 meters. Estimate the rate of heat transfer. What is the value of Q? Is asking. Okay. So the procedure is very, very simple compared to the plates. You observe what is the procedure we are going to follow. Okay. So if this is a sphere, air is blowing over the surface. So here we will not divide the region into laminar and turbulent. So once the air is blowing, once you finalize with RE, we will come to know whether the flow is turbulent or laminar. That's all. Here there is no separate region called laminar region and turbulent region. So for this arrangement, there will be only turbulent flow or laminar flow. So first we'll find out TF. As usual, what we did. TF is the first step. That is film temperature is T wall plus T infinity divided by 2. This is standard for either for plate, cylinder or sphere. T wall is 130 plus 30 divided by 2. So 80 degree centigrade. Then what is the fluid here? What is this fluid given? The fluid is air. Air is a fluid for you. So the second point is properties of air at 80 degrees centigrade. What are the properties we are supposed to take? Can you tell? Rho, mu, Prandtl number, rho, mu, and thermal conductivity. These four properties are enough. Rho, mu, Prandtl number, and thermal conductivity. So you take the properties of air at 80 degrees centigrade. So shall I write the values? I will write the values. You please cross check. If you're having data inbox, you open and check out. And then, okay. So instead of taking this value, rho and mu, instead of taking this rho and mu, what I have done, I have taken the value of kinematic viscosity. Instead of dynamic viscosity, I have taken kinematic viscosity. You know the relation between these two. Mu into rho is called kinematic viscosity. So this value is 21.09 into 10 to the power of minus 6 meters square per second. And Prandtl number is 0.692 and K is 30.47 into 10 to the power of minus 3 watt per meter Kelvin. So either you take rho, mu and everything, or you can take directly the kinematic viscosity. Once you know the properties, we go for Reynolds number. What is the Reynolds number? Rho V. We supposed to take till now L because the length of the plate. Now it is given with respect to the sphere or cylinder. Either it will be sphere or cylinder. Instead of L, we will take rho V D by mu. So what is rho by mu? This rho by mu we can write it as kinematic viscosity. Sorry. V into D divided by kinematic viscosity. That is V is nothing but U infinity diameter by kinematic viscosity. So U is 0.5 into diameter is 60 into 10 to the power of minus 3 divided by kinematic viscosity is 21.09 into 10 to the power of minus 6. So this is the formula. Try to get the Reynolds number. See, for all the problems in the previous case also, rho VL by mu. Instead of this, you can also write VL by nu, kinematic viscosity. That is U infinity L by nu if it is plane. If it is sphere, it will become D. If it is cylinder, then also it will become D. Clear? See, why I have given this formula only for this problem is just to make sure that in some problem he will give, say for example, properties of air. If it is 72.5, instead of interpolating, in that case, if he has given, so instead of giving rho and mu, if he has given kinematic viscosity nu, then what he will do? You know only formula rho v d by mu. Kinematic viscosity, if he has given, then instead of this formula, use this formula. And then simplify. This is nothing but simplified version of rho by mu. What is the Reynolds number value? Anybody? Hello. Reynolds number value. Anybody got? Or anybody having doubt? Please ask me. Ranveer is there? Gautam? Okay. Himanka is given answers 1422. Let's check. 1422 for 0.47. 1422.47. So after the Reynolds number, what we did in the plate, do you remember? We have written a note. Okay, what is the note we have written? I'll show you. Open the data handbook of page number. What I shared. Page number. Okay, 119. In the data handbook, what I have shared, open the page number 119. That is flow over spheres. Flow over sphere. Flow over sphere. In that, there is one formula for NU. There are so many formulas of NU depending upon the cases. So very first equation will be the generalized equation. You can apply for all the type of problems. What is that NU? In that, so first we'll write a note. What is the note we are going to write here? Whether it is a laminar flow or turbulent flow, that is required for us. So in the next line of the flow over spares, he has given NU is equal to 0.37 into RE to the power of 0.6. I can use that only that equation if the Reynolds number is less than 17 and greater than 17 and less than 7,000. Okay. Instead of writing note, you can write directly that value. NU is equal to 0.37 RE to the power of 0.6. So only this Nusselt number formulas will change depending upon the flow, type of flow, depending upon the fluid used, depending upon the shape of the material. If it is plate, Nusselt number formula is different. If it is plate with respect to laminar, again Nusselt number is changed. If it is plate with respect to turbulent, Nusselt number is changed. If it is plate, instead of air blowing, if it is some fluid is blowing, Nusselt number is changed. If it is cylinder, Nusselt number is different. If it is sphere, Nusselt number is different. So why I taken this Nusselt number? He has given below this the Reynolds number if it is greater than 17, less than 70,000. We got now only 1,422, which is in between the range of 17 to 70,000. So we have selected this Nusselt number for flow over the sphere. So Reynolds number we got, everything we know here. Find out the Nusselt number. What is the Nusselt number value in this? So Nusselt number value we'll get from this as 28.84. 28.84 is the Nusselt number value. Okay. 28.84 is the value of Nusselt number. After this Nusselt number, what we did? Do you remember in the plates? Procedure is saying after the Nusselt number, we equated the Nusselt number into H L by K. So instead of that L, as I told, HD by K because it is sphere. Instead of L, I'll substitute D. HD by K. You know, H is unknown. We are supposed to take H here. H is equal to NU K by D. NU you got here. K is the property of the fluid. D is the diameter of the sphere. So totally we will get H is equal to how much? 14.64. 14.64 watts per meter square Kelvin. This is the value of H. So here, find out the value of H. First, I will tell you. After this H, I will tell you important thing. Find out the value of H. H is, as per my calculation, it got H is equal to 14.64. If there is any changes, please let me know. Okay. After this, what we did, do you remember? After finding the value of H, we understood that is the value of Hx. Then we went for H average, correct? But here, there is no H value based on the X. Whatever the H value we are getting, that itself is an average. Because in the plate, based on the value of X, the value of H goes on varies. But here, hence it is a sphere. We cannot define the value of H with respect to X. So we will keep that itself as an H average. Keeping that itself as an H average, Q is equal to H A delta T, that is T wall minus T infinity. So what is H now? 14.64 area. What is the area for the sphere? 4 pi r square. This is the only change. There we used to substitute area as surface area of the top surface. If it is flowing both the sides, 2 into area we used to substitute. Now this is the area for the sphere into T wall is 130 minus of T infinity is 30. So find out the Q in batch. Anybody?
So here we have to substitute hx value directly.
Directly, because that hx here in the plate, what we did, he used to ask based on the x direction. See, here the value of h will be different. Here the value of h will be different. Here the value of h will be different. So we should not substitute h locally. What we did, we have converted this length of the h, means here the value is h of the h value is different. Here it is different. Here it is different. So instead of taking different values, we have converted that all the lines into average line. That average, if you convert, it will become 2 into hx. In laminar flow and turbulent flow is, it is 1 by 0.8 into hx. But here, there is no question of h value of different diameters. No, see, this is the diameter given. If the air is blowing, you cannot tell with respect to diameters, different diameters, what is the value of h. H will be same throughout. So, h, whatever we are substituting, that itself is an h average and we'll substitute in the value of q.
Okay, got it, sir.
Okay, what is the q value?
So 16.55.
16 or 15?
16, sir.
16.55 watts. So this is the value of Q, what we got.
So in which page the formula of NU is there?
The formula of NU, which one? Whether you want this formula or the other one?
No, sir. Yes, sir.
Other one.
The other. Yes, sir.
The other one is in that handbook what I have shared. It is in the page number 119.
Bro, it's 128, bro.
Huh?
128 is a page number.
Oh, for your data handbook, huh?
Yeah, sir.
Okay, because I'm having only the data handbook what I have shared now. Okay, in the data handbook what I have shared, it is 119, and the heading is 3 flow over spheres. You check out flow over spheres and then take the values of Nusselt.
Yes, sir. Got it, sir.
Okay, fine. So here, if you, in this chapter, the solution is very, very easy. For any problem, it may be first step should be T film. Second step should be properties. Third step should be Reynolds number. Fourth step is important for any problem in this chapter. Fourth step, that means selecting the value of Nusselt number, formula for Nusselt number. You should read the question carefully. Concentrate on the Reynolds number. Concentrate on the Prandtl number. Based on these two and the given shape, you should go for Nusselt number formula. If it is sphere, open the sphere topic, take the Nusselt number with respect to sphere. If it is plate, like that, the formulas of Nusselt number, that will change. After that, remaining procedure same again. Nu is equal to HL by K. Then we'll get H there, H average, Q, remaining procedure is same. Only here, the challenging for you is to identify the value of the formula for Nusselt number. Depending upon the fluid used, depending upon the type of the flow, depending upon the shape, you're supposed to select the Nusselt number properly. Because if you see the data handbook, there are plenty of Nusselt numbers, more than 100 Nusselt numbers you get. So which one you're supposed to select? That should be based on Prandtl number, Reynolds number, fluid, and the shape. Based on these 4 characteristics, we are going to select the formula of Nusselt number. Okay? I hope you understand. What is the next problem? Can anybody tell? See how fast we completed the sphere problem. Sphere and cylinder problems are very, very simple compared to the plates. Because there we have to check first whether it is critical Reynolds number, what is the length, everything we have to check. Here it is very, very simple. Can anybody tell what is the next problem?
Refrigerant copper tube 12.5
Okay,
mm.
okay. Refrigerant. Huh? I'll open that. Okay. A refrigerant just a moment. Okay. A refrigerant copper tube, 12 point. See, it is a copper tube. That means the problem given in the form of cylinder, not in the form of sphere or plate. So tube here is given, no? So we'll take it as a cylinder. The problem is given based on cylinder. And what is the diameter of the cylinder? D of the cylinder is 12.5 millimeter into 10 to the power of minus 3 meters. Length of the cylinder is 2 meters. And is maintained at a temperature of minus 20 degrees centigrade. That means this tube is maintained at minus 20 degrees centigrade. That means T wall is equal to minus 20. See, this is the first problem what we are solving. This case may be for sphere also. Minus 20, the wall temperature will be 20 for plate also. But the procedure is same. Okay, 20 degree. And exposed to air, T infinity is equal to 40 degrees centigrade. Now, the air temperature itself is greater. Compute the heat gained by the line due to forced convection if the air velocity is U infinity is equal to velocity is equal to 5 meter per second is blown. So he is asking you to calculate only Q. So here also very simple. He won't ask you to find out CFX, CFX average, and then force, power, nothing. Only he will ask Q if it is a cylinder or sphere. Very simple concept. So that means what? There is a cylinder where length and diameter is given, air is blowing at the velocity, T1 and T infinity. Again, okay, I'll draw a cylinder. So assume that this is a cylinder where air is blowing. The cylinder is having lesser temperature compared to the air. The fluid is air. That is also important. You should know what is the fluid used. Fluid is air. So what is the first step? T film. T wall, T infinity by 2. See, I'll write the formulas first. You go on telling the answers. Then properties of air at TF. So here we want rho, mu, Cp, K. Sorry, Prandtl number and K. If rho and mu, if you're not taking, no problem. You take the kinematic viscosity. Any one. I told you the formula. If it is kinetic viscosity, what to do? If it is rho mu, what to do? All this property, kinematic viscosity is also there in the time. Page number something. For TF, you can get any values in this, all the values in this. Then third step is Reynolds number. What is Reynolds number? Rho V D by mu. This is a standard formula. Instead of L, I am substituting D because it is a cylinder. You may ask, L is also given here. The length of the cylinder is given. Why you are not substituting L? Because we should concentrate only where the air, which is, see, for example, this is a cylinder. If this is a cylinder, air is blowing. The effect of air is throughout the surface of this diameter, throughout the diameter. So we are taking rho V D instead of L. For sphere and cylinder, you take D. And if for plate, you will take L. So this can be rewritten as rho U infinity D by mu. Or it is also possible to write U infinity D by kinematic viscosity. Either you use this formula, you get the same answer. Tell me the answer of Reynolds number. And many of you have not submitted the assignment 2. I don't know what is the reason. So for this, U infinity is 5, diameter is 12.5 to the power of minus 3. Kinematic viscosity is, we'll get from here. Or we can substitute rho Vd by mu. That is also okay. Anybody got the answer?
So it's 4415.7.
4415.7. That is the Reynolds number. So fourth step is important now. We are supposed to select the Nusselt number. See, to select the Nusselt number, before going for the data handbook, you observe the conditions. You know, you concentrate on the Reynolds number, you concentrate on the shape, you concentrate on the fluid, and also based on PR. So what is the Reynolds number? Reynolds number is 4415, and the configuration given is a cylinder, fluid is air. Go for the data handbook with respect to the cylinder. Now we found out with respect to sphere, no? Similarly, go for sphere, cylinder. Cylinder is in the page of 115. He has given flow over cylinder. Flow over cylinder. Flow over cylinder. Did you got? in the data handbook, what I have shared in the Google Classroom, it is page number
Yes, sir.
115. Okay. So can you tell formula what is the Nusselt? To select the Nusselt number which is at the beginning, it is generalized equation. What is the condition he has given? To select that Nusselt number, that is Nusselt number. Okay, I'll write this. Nusselt number is equal to C into RE to the power of M parental to the power of 0.333. So whether this is correct, whatever the formula I selected is correct or not, just you check out from this. He told for the value of C and M, refer below. So we'll get here. We'll get the below table. See, that means in the table what he has given, the Reynolds number starts from 0.4 and maximum is 4 lakhs. So if the value of Reynolds number what we got is in between 0.4 to 4 lakhs, that formula holds good. That is the meaning of that table. Understood? What is the minimum value in the table? 0.4. What is the maximum value of Reynolds number in the table? It is 4 lakhs. So within the range of 0.4 to 4 lakh for a cylinder, you can select this formula. That is NU what I selected is correct. So what is the Reynolds number we got now? We got this 4,415.7. So it is well within the range of 0.4 to 44 lakhs. So where is this 4415? So what you have to take the value of C and M from the table for the range of 4,415. So it is lying in the range of what? 1, 2, 3, 4. Fifth row. Fifth row. Check out the fifth row of Reynolds number. That is in the range of 4,000 to 40,000. We are in the range of 4,000 to 40,000 now. So what is the value of C? C is equal to 0.193 and the value of M is 0.618. Artha agtidiya? Anybody having doubt? Hello? Okay, I hope there is no doubt. This values from the table. So with these values, substitute C, Reynolds number we got, substitute M, Prandtl number we got from the properties. So this is a formula for the flow over the cylinder. And if the Reynolds number is in the range of 0.4 to 4 lakhs. If it is exceeding 4 lakh, there is one more formula that will go later. If it is less than 0.4, there is one formula. Again, any problem it won't be less than 0.4. Rho VD by mu will not be less than 0.4. It is short. The only possible way is it may be exceeding 4 lakh. We will see that if it is exceeding what to do. As per my knowledge, whatever the problem he has given till now, it will be lying within that range only. Within the range of this 0.4 to 4 lakhs. Okay. So you'll get the value of C, we'll get the value of M, find out the Nusselt number. So what is the Nusselt number we got?
So 30.54.
Huh? 30.
Yes, sir.
Okay. 30.54. Nusselt number is 30.54. No units. Next. So what is the next step we need to follow? Substitute the Nusselt number in H D by K. Take out H from this. So H is equal to Nusselt number into K by D. So what is the value of H? So this formula where you will get H is equal to, sorry, NU is equal to HD by K. This formula we will get from page number 111. 111. You can find out the Nusselt number formula. And this Reynolds number also from page number 111. Any non-dimensional numbers formula we will get from page number 111 in the data handbook what I have shared. So can you tell what is the value of H? The board is visible. Hello?
Yes, sir.
Yes, sir. Yes, sir.
Okay. There is no reflection problem. No. Hey Dhanush, why you type the message now only, man? I'll ask when to give the user. ಈಗ ಬೇಡ.
Sorry sir, ನಾನು ಅದು ರೆಡಿ ಮಾಡಿ ಇಟ್ಕೊಂಡೆ ಬೈ ಮಿಸ್ಟೇಕ್ ಆಗಿ ಬೈ ಮಿಸ್ಟೇಕ್ ಸರ್.
ಆಯ್ತು.
ಅದು ರೆಡಿ ಮಾಡಿ ಇಟ್ಕೊಂಡಿದ್ದೆ. ಐ ಪ್ರೆಸ್ ಸೆಂಡ್.
Can you tell the answer? H value, anybody?
So 61.76.
Okay, 61.76 watts per meter square Kelvin. That is the value of H. Once you know the value of H, you go for as usual Q. So what is the Q for this formula? Q for this value of H, H is equal to Q is equal to H A into T wall minus of T infinity. So H value is 61.76. Area is pi dl. This is the area. Pi dl is the area for the cylinder. For sphere, 4 pi r square. For plate, W into B, width into breadth. T wall, what is T wall here? Minus 20 minus of 40. Minus 20 minus 40. This one, minus 20 is important in this case. So what is the Q value?
So minus 291.048.
Yes, minus 291.048. That means you'll get the value, because why you are getting negative? Because the heat is gaining. The copper tube is taking the heat from the surrounding air. So we got minus. So either if you substitute minus also no problem, without also no issue. 291.0.
0.048.
But either you want, you can substitute minus or not, no issue. If you substitute minus, it is understood. If you are not substituting minus also, it is understood. Because the pipe temperature is lesser compared to the air temperature. So, see, any diploma students are there here in the class? Any diploma students? Huh?
Yes, sir. Gunasagar.
Gunasagar, why that Shiva Pavan or Shiva Krishna is not attending the class?
I don't know, sir.
If you are having his number, you can please call him and ask. Okay.
Okay, sir.
So I think probably you got this Q. Next. Which is the next problem I given? Which is the next problem? Here we go. Next problem, I think it is assuming that a man, correct?
Yes, sir. Yes, sir.
See now, that problem I will explain. You check out whether it is possible for you to solve or not. A man, assuming that a man can be represented by a cylinder. So instead of giving directly the cylinder, he is asking that a man is considered as a cylinder 30 centimeter in diameter. The man is 30 centimeter in diameter, having 1.8 meter length. Okay. With the surface temperature of 37, calculate the heat he would lose while standing in 24 kilometer per hour wind at 3 degrees centigrade. That means the velocity of the air which is flowing is 24 kilometer per hour. We are supposed to convert into meter per second. Convert that into meter per second. And the wind temperature is 3 degrees centigrade. And the diameter of the person or diameter of the cylinder, we'll consider it as a cylinder. Cylinder is 30 centimeter. Length is 1.8 meter. And the temperature of the person or cylinder is 37 degrees centigrade. Can you find out the value of Q for this? So just I'll write the data. See, all the notations are same here. Diameter, instead of cylinder, he has given person or a man, consider it as a cylinder. Diameter is how much? 13 to 10 to the power of minus 2 meters. length is 1.8 meter, and what is the temperature of the body of a person? Temperature of the body is 37 degrees centigrade. Surrounding air temperature is 3 degrees centigrade. Velocity is 24. He has given 24 kilometer per hour. So 24 into 10,000 divided by 16 to 60. So we will get, what is the U infinity? 6.66 meters per second. So the wind is blowing at this speed. What is the Q? So can you find out this Q for this problem? Can you find out the Q for this problem? Hello? Hey, whether you can solve or not, or whether I should solve the class. This is same as the previous problem. Instead of giving cylinder directly, he has given consider a man as a cylinder and the datas he has given the datas. In the previous problem also, these are only values he has given just by changing the values. D is given L, T, W, T, infinity, U, Q. Everything was given same, but the values are different. We have found out the Q. Here also, first you find out TF. Take the properties at TF. Once you know the properties at TF, find out the Reynolds number. Definitely here also Reynolds number will be within the range of 0.4 to 4 lakhs. So what is the Reynolds number? Based on that, you find out C, you find out M. C and M, both we will find it. Then we will find out Nu, Nusselt number, after that H, then H, after that H, we will find out Q. I hope you can do. Can you do or not?
Yes, sir, will do.
Please try to do by yourself. Okay, don't consider it as an assignment. You try for better understanding. That's all. Because cylinder, I have solved one problem. Similar way, this is the problem what I given. Okay. Next. Which is the next problem I given? Which is the next one given? Hello, Sagar. Sagar.
It's a vertical cylinder.
Okay, that is the last problem in this today's class. Last problem, correct?
Yes, sir.
Okay, I'll go with that. He has given a vertical cylinder of 30 centimeter diameter, 2 meter length. Okay, I'll change this. 30 say 2 meter length. Cylinder with 2 meter length with a temperature of 30 degrees centigrade. T was instead of 37, it is given 30. Is placed in an air. Calculate the heat loss when it is placed in 36 kilometer per hour wind. That means instead of 24, he has given 36 kilometer per hour. So if this is 36, it will be something else. Conversion is, he has given 36 kilometer per hour. So you convert that. Next. The wind is having at a temperature of 10 degrees. Instead of 3 degrees, he is having, the wind is 10 degrees centigrade. That is case 1. Find out the Q. Also, calculate the rate of heat transfer if the above object is a square in cross section having same height, surface temperature, volume, and exposed to the same velocity of air stream. Very good. See, here's what he has given. Case 2 cases he has given. Case 1, he has considered it as a cylinder. He has considered it as a cylinder where air is blowing over the cylinder, some diameter, length, everything is given. You know how to calculate till the Q. Then coming for case 2. So what is the case 2 given? Considering the volume of the cylinder and the case 2 body is same. Velocity, everything remains same, except the shape of this will change. Now it is given a cylinder. In the next case, he has given square block. So instead of cylinder, if he has given a square, he's asking you to find out the Q. He's asking you to find out the value of Q. Understanding? The volume of this, volume of that is same. Velocity here, there also it is same. Temperature here and there, it is same. Everything remains same, except the shape. Here it is diameter, there it is a square. But there, dimension is not given. Length will be same, correct? What is the length here? It will be 2 meters. Here also it will be 2 meters. But here, the diameter is 30 to 10 to the power of minus 2 meters. We don't know this. First, we have to calculate this. How will you calculate this? He has given the volume is same, correct? He has given the volume same. He has given the length of the material same. And both the materials are made up of same material. Both the bodies are made up of same material. So can you able to calculate this values? That is area, cross-sectional area, this cross-sectional area of the body. Once you know the cross-sectional area of the body, we can easily calculate this value, breadth into width. So first what we will do, we will go for this cylinder. Say, I'll not write the values, just I'll write the formula. First you go for TF, second you go for properties, third you go for Reynolds number. So here while you're substituting rho V D by mu for this case. So based on this, we'll go with Nusselt number. So again here also Reynolds number will be well below 0.4 to 4 lakhs. You can find out this Nusselt number here. Fifth, Nusselt number we can find out from this H. Sixth is Q. Very simple steps. There also same steps. There also we are going to use the same step, except here instead of rho VD, what we supposed to substitute can tell. See, assume that this is a square block, means a square where air is blowing. So this breadth and width is same. So that here what did I told? If it is a cylinder, we should consider rho VD diameter means throughout this cylinder how it is flowing. So we should consider D. There it is a square. Once the air is coming and hitting this, it is going to flow over the surfaces. So instead of D, what I supposed to consider that? Instead of D, what I supposed to consider? I supposed to consider
length.
Which length? Length is this, no. Length is 2 meters. Whether I should consider length?
Breadth, sir, breadth.
Yes, we should consider. See, I will write instead of question mark, I'll write here. This is, we'll consider it as a breadth and width. So hence it is square. Hence he has given it as a square. Breadth will be equal to width, correct? So we have to consider the value of breadth. So what will be the Reynolds number value then? Rho V B divided by mu. This is the Reynolds number value. Why B? Why not L? Why not D? You should understand. So I told in heat transfer, configuration is very important. Considering the configurations in the formulas are important. You know the formula is rho V L by mu if it is plane. If it is cylinder, we should consider the entire diameter. So we take rho V D by mu. If it is square, we consider the same surface. So the surface means the breadth. The breadth we have to consider here. So this breadth is not given. We have to calculate the breadth. Except calculating the breadth and except substituting Reynolds number in the breadth, everything is same. Procedure for all, the entire till the Q, it is same. So how to find out the breadth? Can anybody tell? How to find out the breadth? So only I'll explain that.
So it's same as length.
No, to find breadth, he has given volume for cylinder is equal to volume for the square rod. We'll take it as a square rod. Volume for cylinder. So what is the volume for cylinder? 5 by 4 into, what is the cylinder volume? D square into length. Here volume for the rod is L into B into H. Sorry, L into B into W will take. So this length and this length is same. 5 by 4 D square we know, something will get here. So W into B will be that value, so that W or B will be half of that. So B is equal to W is equal to pi by 4 D square whole divided by 2. Correct? That is the value of B. You find out the B, value or width value and tell me the answer fast.
So it will be root over that.
Huh?
B equal to W equal to root over pi by 4D.
Oh, square. No, correct. Sorry. Okay. What is answer? So what is the answer of B or width? Hey, ಬೇಗ ಹೇಳ್ಬೇಕು. What is the value of B? That is equal to W is equal to, shall I write the answer?
So 0.265 meters.
265 meters. So that means you should substitute this B here in this B here. So here also TF, there is no change in case 1, case TF is not changed. Properties is not changed. Only the Reynolds number, instead of D, we are supposed to substitute rho V B by mu. Then go for Nusselt number. Nusselt number, what you will use, which formula you will use? Okay. See, next class, do one thing. You please be ready with the B. Case 1, you find out and get the answer of Q. Be ready with that. Case 2, you find out till B and also Reynolds number. Be ready. I will go with further cases, further continued part of that. Okay. So now, all of you, please type your US number. Go for the next class. Type your US number. You can go for the next class. Any doubts, you can ask me in the WhatsApp. So before coming for the next class, be ready with the Reynolds number for case 2. Q for case 1 should be calculated. So all of you, please go for the next class. Type your US and you can go for the next class. Fast.